Hello everyone, welcome to 1.1. This is linear equations. So to start off, an equation is just a statement that two expressions are equal. So it could be something like x plus 3 is equal to 8, 11y is equal to 4y plus 7y, or x squared minus 2x minus 1 is equal to 0. So all it's doing is equating two different expressions. Now, solving an equation means finding all of the numbers that make the statement true. Okay, so it's in the case of something with a variable, it's going to be what numbers can we plug into this variable in order to make this equation true, to make both sides of those equations equal. Okay, so we've got linear equations. These are equations with a single variable, and they can be written in the form a times x plus b is equal to 0, where a is not equal to 0, so you have some number here, at least 1 or something like that, right? And a and b are real numbers, so no imaginary numbers. They can be fractions, they can be decimals, or whole numbers, but no complex values. Okay, so these are first degree equations because the highest power of the variable is just 1. Okay, so these are not quadratic equations or cubic equations or anything like that. Let's look at our first example here. This is saying to solve 3 times, in parentheses, 2x minus 4, which is equal to 7 minus, in parentheses, x plus 5. So our first step here should be to distribute these multiples. We're going to distribute that 3 across the parentheses. We're going to distribute this negative sign, which is really just a negative 1 across this parentheses. Okay, that's going to give us, on the left side, 6x minus 12 is equal to 7 minus x minus 5. Now our next step is to try to gather like terms. Okay, well, we can combine like terms first on either side, so 7 minus 5 is going to be 2, but we want to collect all the x terms on one side, we want to collect all of the constants onto the other side. So let's move the x's over to the left side. So we can add x here and add x here. So this will be gone from the right side, and on the left side we're now going to have 7x. Okay, and then the same thing we're going to do to the constants. We're going to move the 12 over to the other side. Plus 12 and plus 12. We'll be left with 7x is equal to 14. Now our last step is to try to isolate the variable. We want to get rid of everything, including the 7 in front of it. Okay, so we wanted to make sure we don't have anything added or subtracted to it. We also want to make sure we don't have anything multiplied to it. So we're going to go ahead and divide both sides by 7. And x is going to be equal to 2. In other words, 2 is the value of x that makes that original equation true. Okay, that's what it means to solve an equation. We're attempting to make this equation true, to make sure it holds up. All right, let's look at example B. This says solve 2x plus 4 divided by 3 plus 1/2 x is equal to 1/4 x minus 7/3. So the first thing we'd like to do here is get rid of these fractions. So why don't we just go ahead and multiply both sides by the least common denominator. So our denominators are 3, 2, 4, and 3. And if we were to multiply both sides by 12, that would take out everything. So let's see how that looks. We multiply both sides by 12 and distribute. We're going to get 12 divided by 3, which is 4. 12 divided by 2, which is going to give us 6. On the right side, 12 divided by 4 is going to give us 3. And then here we're going to get 12 divided by 3, which leaves us with a 4, and we already have a 7 there. So this is 7 times 4, which is 28. If you wanted to, you could have done this as 7 times 12 divided by 3. You would have gotten the same thing, negative 28. Okay, and then from here, the next step is going to be to distribute this 4 across this parentheses. we'll get 8x plus 16 plus 6x on the left side, 3x minus 28 on the right side. Let's combine like terms where we can. So we get 14x plus 16 on the left side. The right side stays the same, 3x minus 28. Now let's go ahead and collect our x's on one side, collect our constants on the other side. It doesn't matter which side you do it on. I'm just going to try to do it so that the coefficients remain positive. So I'm going to minus the smaller one over. I'm going to move the smaller x over. Minus 3x from both sides. We'll be left with 11x plus 16 is equal to negative 28. And then subtract your 16 from both sides. 11x is equal to negative 44. Finally, we need to get rid of this 11, this coefficient of x. Go ahead and divide both sides by 11. And x is equal to negative 4. Okay, so negative 4 is the value of x that makes that original statement true. Let's try one more. So again, we've got some fractions here. 1/3 times, in parentheses, 7t minus 4 is equal to 1/6 times, in parentheses, t plus 4. Why don't we just go ahead and again multiply by the least common denominator on both sides and just get rid of those fractions altogether. So we've got 6 over here divided by 3 and 6 over here divided by 6. So on the left side, we'll be left with just a 2. On the right side, just a 1. We go ahead and we distribute those values. We'll have 14t minus 8 on the left is equal to t plus 4 on the right. Now, again, we want to collect our variables on one side and our constants on the other side. So subtract t from both sides, we get 13t minus 8 is equal to 4. Add 8 to both sides, 13t is equal to 12. And our last step, we need to remove this coefficient of t. We need to divide both sides by it. We'll get t is equal to 12 divided by 13. Okay, so that is the solution to our equation. Now real quick, let's talk about identities, contradictions, and conditional equations. So there's 3 major types of equations that we're going to come across, right? So an equation, first of all, that is satisfied by every number is called an identity, as in one part is identical to the other. And here's an example of that. So if you had something like 3 times x plus 1 is equal to 3x plus 3. Well, you can go ahead and you can distribute that 3. And now what you see is you have the same thing on both sides. It's identical. And if we try to solve this in the way that we usually do, we try to collect our x's on one side and our constants on the other. Well, if you subtract 3x from both sides, you're going to actually be left with no x terms whatsoever. You're just going to be left with something like 3 equals 3. Okay? The variable's gone. You're left with a true statement. What this is telling you is that this equation isn't even dependent on the variable. It doesn't matter what that number was. It could have been anything. It would not have mattered. It was going to be eliminated anyway. Okay, so when the variable's gone, you're left with a true statement. This is an identity. On the other hand, an equation that is satisfied by no number is called a contradiction. So this is a very similar case. Suppose you had something like 2x plus 1 is equal to 2x minus 1. We go ahead, we try to collect our variables on one side, subtract 2x from both sides. You're going to be left with positive 1 is equal to negative 1. So the variable cancels, and you're left with a statement that's not even true. These two numbers are not equal. You're left with a false statement. So no matter what you do, there's no possible number we could have plugged in for x to make this work. Okay? It's just not going to happen. So this is a contradiction. And the last kind is an equation that's satisfied by some numbers, but not others, and this is called a conditional statement. or conditional equation, I should say. And that's basically what we've been dealing with until now. So if you have something like 2x plus 1 is equal to 5, you subtract 1 from both sides. 2x is equal to 4. And go ahead and divide both sides by your coefficient. X is equal to 2. So you have a singular solution. It doesn't always have to be one solution. It could be 2, 3, so on and so forth. This concept of identities, contradictions, and conditional equations isn't just limited to linear equations. It's going to be for, your quadratics and cubics and things like that. So in those cases, you may have more solutions for a conditional equation. Okay. And the last thing I want to talk about in this video is literal equations. Okay, so we can use our rules of algebra to solve an equation for a variable, even if it only involves letters. And this is what's known as a literal equation. So let's look at an example. Example D says solve I is equal to P times R times T for R. Okay, so we can go ahead, we can apply our rules of algebra, but we're not going to get a numerical solution. There's no numbers to be found in this literal equation, right? And that's perfectly fine. Okay, so our first step, let's try to isolate R by dividing the other variables away, which are P and T. We want to get rid of this P and this T, which are being multiplied by R, so we divide them from both sides. And you'll just simply be left with I over PT is equal to R. Or you could rearrange it, R is equal to I over PT. Either one is an acceptable way to write this solution. Okay. So that's a literal equation. Now you may have a literal equation even with some numbers, right? So this is still a literal equation, mostly because we can't reduce the solution to anything more than some combination of letters, and this is what we're going to see here. Okay, so we want to solve 3 times 2x minus 5a plus 4b is equal to 4x minus 2, 4x. Okay, we want to isolate the variable x here. So let's go ahead and we'll distribute that 3 first. We'll get 6x minus 15a plus 4b on the left side is equal to 4x minus 2 on the right side. Let's go ahead and subtract the 4x from both sides, get our x's on the left side. 2x minus 15a plus 4b is equal to negative 2. Now again, the same way we always try to isolate the variable, let's move over everything else to the right side. So we'll get that 15a out of here and the 4b out of here. We want just x on the left side. 2x is equal to 15a minus 4b minus 2. Lastly, let's just divide everything by 2. We want to get rid of the coefficient. X is equal to 15a minus 4b minus 2, all of it divided by 2. Okay, so you can see in this is also still a literal equation because of a and b. We cannot reduce this any further. We cannot get a numerical solution for x. Okay, so this has been 1.1 linear equations. If you enjoyed this video, you found it helpful, please like the video and subscribe to the channel for more. And that's all.